Okay, welcome back to Playing with Newton's Laws. Once again, I'm Mr. Skinner. I'm here with my three lovely assistants, Bodie. Bodie, give us a wave. Kendall. Hey, and Naya. We're going to be showing you this new game in my collection, Yeti Set Go, which demonstrates Newton's three laws of motion quite clearly. I'm going to be doing my best to talk while off screen and trying to play this game, and these guys are going to try to beat me. None of my students ever beat me. So, Yeti, set, go. So this one applies to Newton's laws quite clearly, because once you have a ball in a location, it's demonstrating Newton's first law of motion. An object at rest will remain at rest unless acted upon by an outside force. Well, nothing's ever going to act upon it. So they literally stay still. And even these ones down here lower on the hill, they stay in one spot permanently until an outside unbalanced force acts upon them. And the outside unbalanced force in this case is the foot of the Yeti literally kicking it up the mountain. And if it does land in the right spot, it can eventually end up somewhere else on the table. And so that's the outside unbalanced force acting on the meatballs. Okay. One of those over there. Here. Okay. It also demonstrates Newton's first law of motion, in that an object in motion will stay in motion. You'll notice if they put too much force, it launches all the way over and lands in Kendall's lap, and it just keeps on moving as it rolls away. That's what Naya is chasing down. So this is a really nice demonstration of Newton's first law of motion, in that the objects are constantly in motion. Look at that one. See, that was an object in motion. And it's all due to these unbalanced forces. Okay? Now, it also demonstrates Newton's second law of motion, in that it takes a force to accelerate a mass. These will literally just sit here in this spot forever. But as soon as I apply the force, that's the little Yeti's foot right here kicking it, okay, the mass of the meatballs gets accelerated up the mountain, okay, and then sometimes clear across the table, like these happen to be doing. So there's force equals mass times acceleration right there in action. I'm so close to winning. These guys don't even realize that we're winning. Okay? And then it also demonstrates Newton's third law of motion, that force is necessary to accelerate a mass. Okay? Sorry, that's Newton's second law. Newton's third law, for every force, there is an equal and opposite force. Every time you see the inertia of one of these balls hit something, you'll notice it starts to bounce around, especially if it hits the other balls. The other balls react. That's because they are pushing against each other, see? And when they bounce, you can actually also see them pushing against each other as they bounce around. Okay? That is them pushing against each other. For every force, there is an equal and opposite force. Ran away. Ran away, ran away, ran away, all the way over there. A force is an equal and opposite forces. So they're pushing against each other. Technically, the Yeti, if we could get it to talk, it would tell us that it actually feels the kick. And that's the win right there. Mr. Skinner has one in all four levels. And yeah, so she doesn't have one up there. See, Mr. Skinner wins again, once again. But as you can see, Newton's first law, objects at rest remain at rest. Objects in motion, bouncing across the room, they stay in motion. Okay. Newton's second law, force is required to accelerate a mass. Okay. Landed in his, somebody won right there. And then finally, Newton's third law, for every force, there's an equal opposite forces. They're bouncing against each other, ricocheting across each other. They're literally pushing on each other as they bounce around. Thank you, everybody, for coming and watching Playing with Newton's Laws. Bye. Wave. Wave.